Welcome back to Unit 5. In this lecture video, we'll cover content from your Chapter 6, Section 8 lecture notes. We'll be doing some more applied problems involving quadratic equations and quadratic functions. In our first example, we are given that the product of two consecutive positive integers is 182. We need to find those two integers. First, we need to represent these two integers using a variable because they are unknown. Let's represent the first integer with the variable x. Because the integers are consecutive, we can represent the second integer with x plus 1. So now we have our two unknowns. We know that the product is 182, so we can write the equation x times x plus 1 is equal to 182. Multiplying on the left, we have x times x, or x squared, and x times 1, or positive x. Subtracting 182 from both sides of this equation will give us a quadratic equation in standard form. We'll have x squared plus x minus 182 equals 0. Now let's factor the left side. With a leading term of x squared, our binomial factors will begin with simply an x. And now we need two values with a product of negative 182 and a sum of positive 1. Let's list out pairs of factors of 182. There's 1 times 182, 2 times 91, 7 times 26, and 13 times 14. Since we need a negative product, we need one factor to be positive and the other factor to be negative. And since we need them to have a sum of positive 1, we can use negative 13 and positive 14. So our binomial factors are x minus 13 and x plus 14. Now we can set each factor equal to 0. So we have x minus 13 equals 0 and x plus 14 equals 0. If x minus 13 is equal to 0, then x is equal to positive 13. If x plus 14 is equal to 0, then x is equal to negative 14. So now we have two options for the value of x. We're told in this example that we have the product of two consecutive positive integers. So x equal to negative 14 is not the solution that we want. We will instead use x equals 13. And since we know that x is equal to 13, x plus 1, the other integer, is equal to 14. Now we have two consecutive positive integers with a product of 182. Let's look at example 2. In example 2, this time we're given that the sum of two numbers is 20 and their product is 96. We need to find the two numbers. There are two unknowns in this problem, the two numbers that we need to find. Let's represent the first one with the letter x. If the two numbers have a sum of 20 and we know the first number, we can find the second number by subtracting the first number from 20. That is, the second number is equal to 20 minus x. Knowing that the product of these two numbers is 96 leads us to the equation x times 20 minus x is equal to 96. And we know how to solve equations like this for x. Multiplying on the left, we have 20x minus x squared equals 96. And collecting all of our terms on one side of the equation, we can add x squared to both sides and subtract 20x from both sides. This gives us the equation 0 equals x squared minus 20x plus 96. Now let's see if we can factor the right side. We are looking for two numbers with a product of positive 96 and a sum of negative 20. With a positive product and a negative sum, we necessarily need two negative numbers. Let's look at negative pairs of factors of 96. There's negative 1 and negative 96, negative 2 and negative 48, negative 3 and negative 32, negative 4 and negative 24, negative 6 and negative 16, negative 8 and negative 12. And I'll stop there because I found a pair of factors that have a sum of negative 20, negative 8 and negative 12. So the binomial factors in this case are x minus 8 and x minus 12. Negative 8 times negative 12 is positive 96. Negative 8 plus negative 12 is negative 20. Setting both factors equal to 0, we have x minus 8 equals 0 and x minus 12 equals 0. If x minus 8 is equal to 0, then x is equal to 8. And if x minus 12 is equal to 0, then x is equal to 12. Let's first try out our situation with x equal to 8. If the first number is 8, then the second number is 20 minus 8, or positive 12. If instead we let the first number, x, equal 12, then the second number is 20 minus 12, or positive 8. Either way, we find out that the two numbers are positive 8 and positive 12. They have a sum of 20 and a product of 96. In example 3, we have that the area of a rectangle is 150 square inches. If the length of the rectangle is 5 inches less than twice its width, find the dimensions of the rectangle. Let's start by drawing a picture. Here we have a rectangle with area equal to 150 inches squared. We need to figure out the dimensions of this rectangle. That's the length and the width. We are told that the length of the rectangle is 5 inches less than twice the width. That is, the length is equal to 2 times the width, take away 5. That means that our two unknowns in this case are the length, 2w minus 5, and the width, w. We also know that the area of the rectangle is 150 square inches, which means that the length and width have a product of 150 square inches. So we can write the equation w times 2w minus 5 is equal to 150. And this is an equation that we know how to solve. Multiplying on the left, we have w times 2w, or 2w squared, and w times negative 5 for a minus 5w. We can now subtract 150 from both sides, and this will be a quadratic equation in standard form. We have 2w squared minus 5w minus 150 equals 0. Now let's factor the left side. We can factor this using guess and check or factoring by grouping. Let's practice our factoring by grouping. To factor by grouping, we need two values with a product of a times c, which in this case is 2 times negative 150 or negative 300. They also need to have a sum of b, which in this case is negative 5. The two values that will work are negative 20 and positive 15. Negative 20 times positive 15 is negative 300, and negative 20 plus 15 is negative 5. So we split the term negative 5w into negative 20w plus 15w. This gives us the new equation 2w squared minus 20w plus 15w minus 150 equals 0. Looking at the first two terms, we have a greatest common factor of 2w. Factoring out a 2w leaves us with w minus 10. Looking at the last two terms, we have a greatest common factor of 15, which leaves us with a w minus 10. Now we can factor out the w minus 10 from these two groups. This leaves behind 2w plus 15. Now that we've factored, we can set each factor equal to 0 and solve for w. We have w minus 10 equals 0 and 2w plus 15 equals 0. If w minus 10 equals 0, then w is equal to positive 10. If 2w plus 15 equals 0, then 2w equals negative 15 and w equals negative 15 over 2. We don't want w equal to negative 15 over 2 because a rectangle cannot have a negative width or a negative length. This leaves us with w equal to 10. And returning to the original relationship that L equals 2w minus 5, we have that the length is equal to 2 times 10 minus 5, or 20 minus 5, or 15. That is, our rectangle has a width of 10 and a length of 15. Also notice that 15 times 10 is 150, which is the appropriate area. Moving on to example 4, we have a problem involving a projectile. A projectile is launched upward from a platform that is 192 feet above the ground. The initial velocity of the projectile is 64 feet per second. Let's quickly sketch a picture. Here we have a platform that is 192 feet tall and an object that's about to be launched upward. We anticipate that the object will go up for a little while before falling to the ground. We're asked to first find a function, h of t, that gives the height of the projectile in feet after t seconds. In order to do this, we need to introduce a formula that models the velocity of a projectile. H of t is equal to negative 16t squared plus v naught times t plus s. V naught is equal to the initial velocity in feet per second, and s is the initial height in feet. So if we are given an initial velocity in feet per second and an initial height in feet, we can write the function that gives the height of the projectile in feet after t seconds. Let's fill in the information from our scenario into this function. We have h of t is equal to negative 16t squared plus the initial velocity of 64 feet per second times t plus the initial height of 192 feet. Now we have our function. The second thing we need to do is figure out how long it will take for the projectile to land on the ground. That's how many seconds from the time of launch it takes for the projectile to have a height of 0. In other words, we need to find when h of t is equal to 0, or when negative 16t squared plus 64t plus 192 is equal to 0. We can first factor out a greatest common factor of negative 16. This leaves us with t squared minus 4t minus 12. And factoring the remaining quadratic, we have negative 16 times t minus 6 times t plus 2. This gives us values of t equal to positive 6 and t equal to negative 2. We don't want an answer of negative 2 seconds, that's 2 seconds before launch. So our solution is t equal to 6 seconds. That's 6 seconds after launch the projectile will land on the ground. The third question is, what is the domain of the function h of t? The domain is all options for input values. And in this case, our input values are values for t in seconds. Think about which values for t make sense in this function. First, it doesn't make any sense to have values for t that are negative or before launch. So our domain begins with time 0, the moment of launch. It also doesn't help us to plug in values for t that are greater than 6. That's after the projectile hits the ground. Any value for t between 0 and 6, however, will give the height of the projectile in feet between the moments of launch and hitting the ground. And that will conclude this lecture video of applications of quadratic equations and quadratic functions.